This is a Venn diagram. It's made up of 4 regions, 1, 2, 3, 4. Now, region 2, you can see that would be the intersection. So this would be the intersection of A and B. Region 1, you're just in A and you're not in B, so this would be A and not B. So if you ever see that complement sign, that's where you're at. This is region 3, you're in B, but at the same time you cannot be in A. So region 3 is you're in B and at the same time you're not in A. And to be in region 4 means you're not in either one. So you're outside of A and you're outside of B. So that little apostrophe means the complement of, it's you're outside of A and you're outside of B. Now if we said what's the probability of A or B happening, then remember that's made up of any region where you are in A or you're in B or you're in both. So this would actually be 3 out of the 4 regions. Some of the most common problems, you're going to be saying, hey, at our particular high school, 20% of the kids are in sports, 50% are in clubs, and 10% are in both. So find the probability that someone is in sports or clubs. Well, what you do is you take this information, you say, okay, this Venn diagram is going to have 2 little circles or ovals, and they're going to represent all the people that are in that particular event. This is like a two-way table again. But so people who are in sports and clubs, whatever, there's 4 regions. What you're going to want to do when you start filling in the numbers into this Venn diagram, into the 4 regions, start by going to the most restrictive one. Go to the intersection first. You know that 10% are in both, so we could put a 10% there. Then you say altogether there's 20% in sports, but wait a second. There's 2 of these regions that together make up all the kids are in sports. You've used up 10% of your 20% there, so that just leaves 10% there. So that's the main reason why you want to go to the intersection first, because if the kid put in 20% here and then realize later that that's 10%, they'd cross out the 20% and make that 10. So just start with the most restrictive place and work out from there. We know that 50% altogether are in clubs, but clubs are made up of 2 regions. We have 10% here, so now that's how we show altogether there's 50% in clubs, while there's 10% in both. This adds up to 60%, so that means there must be 40% of the kids that are neither in sports nor clubs. So that's our Venn diagram, our universe, our entire sample space is what's that called, is what that is called, okay? Want to find this probably right here. We see the word or. Remember in mathematics, you could be in sports, or you could be in clubs, or you could be in both. You add those guys up, you get the 0.6. You can also use that formula right there. Probability of being in A is 0.2. Probability of being in B is 0.5, but you have to subtract the probability of being in both, which is the 0.1, and you would end up with the same 60%. Okay, now what's the probability that a person's in sports given that they're in clubs? Well, we got 2 ways to do this. Remember, this is the conditional probability formula. Take the probability of the intersection that they're in both, so that would be the 0.1, and divide it by the probability that someone is in clubs, which altogether is 50%, where it's given to you right here. So you divide that by 0.5, that's 1/5 or 20%. So that would be 0.2 as your final answer. Remember, you can shrink the sample space down. We were given that the person was in clubs. So you can eliminate those people and those people, so it shrinks it down to just 50% of the population. So we shrink the sample space down to the thing that was given, the 50% who are in clubs. Now what's the probability that the person is in sports? And once again, it's that 0.1 that's part of the sports event, so it's still 0.1 out of 0.5. Then we could do this. What's the probability they're in a club and they're not in sports? So and means intersection. So go find the intersection of people that are in a club and at the same time they're not in sports. Well, these people are in clubs, but they are in sports. These are the people that are in clubs and at the same time they're not in sports. So this probability would be 0.4. Then we go here. What's the probability that somebody is neither in neither of the 2 or they're in sports? Well, out of the 4 regions, you go select anybody that's neither, so that would be these people, or they're in sports, so you pick up these ones and these ones. So altogether, when you add those up, you get 0.6. So that's it. Those are Venn diagrams, and that's how you can approach them.